Okay, so we've got a bunch of figures, and we want to find some areas and volumes and perimeters and circumferences. Okay, take this figure, this is a parallelogram, right? So I think everybody recognizes that as a parallelogram. And if you want the area of a parallelogram, you multiply its base by its altitude, okay? So you get an equivalent area if you cut off this part and paste it on here, which then makes this into a 12 by 8 rectangle, okay? And it's useful to be able to look at it like that. Now you've got a formula you can memorize where you just multiply the base by the altitude. Our most common mistake is people multiply the base by this side here, okay? And when I said that was 8, that was what I was about to do. I copied it wrong. Okay, the altitude is 7, right? Okay, what am I looking at the front? Okay, so you get 12 times 7 either way, but visualizing the reconstruction, even sketching out the reconstruction isn't a bad idea. Okay, so okay, the area is a base times the altitude, which is 12 times 7. I don't know why I want to keep using 8. And that's 84. Okay. I would look at my picture before I write it down, and I'd probably get it right. Okay. And the perimeter is pretty easy. You got 12 here and you got 8 here. So to go around it, you got to go 12 and then you got to go 8. Now to get all the way around, you got to do another 12 and another 8, right? Okay. So this is 12 and this is 8. So that the perimeter is 2 times 12 plus 2 times 8. That's 24. That's 16. That makes 40. Make sense? So that's how you want to look at it. Okay, here. Perimeter's easy. There's this, which is 34, I believe. Don't forget. That looks familiar. Okay. That's 13. That makes 22. That makes 34. Okay. And then you can't get the area of this because they give you all the information. Okay. Area needs altitude. You don't have the altitude. So you would not have been able to calculate the area of this thing. Now, if I give it an altitude, so I'm going to go ahead and say the altitude here is like 6.5. Okay. So if the altitude is 6.5, I felt I had to write it over here. Average base is 6 plus 12 over 2. Okay, which is 9. And that's what we would get if we deconstructed this thing. Remember, we deconstruct this by going to the middle of this line, taking this little triangle and pasting it up here, and then the same thing here. So we take this triangle and paste it up here. Okay. And now it's pretty easy to argue that this distance is halfway between 6 and 12, because I've taken half of the extra distance over here. Well, I don't want to wave my hands over that. Just if you reconstruct it like this, you can reason out that it would be the same as a 6 by 9 or 6.5 by 9. Okay. This would be 9. Not because this is 9, because 9 is halfway between 6 and 12. I'll say it. No. The statement would be too complicated. We don't want to get into all those details. You've got a formula, 1/2 B1 plus B2 times H, whatever the letters they use. And you can use that formula, but it's really a good idea just to expand your geometric thinking a little bit to understand how that's deconstructed. Again, that's something you could probably do on a test. Next problem, I think I said, if I put something like that on the test, be an optional problem, which means you're welcome to try it. If it doesn't help you, I ignore it. If it helps your grade, I include it. Make sense? Okay. The altitude is 6.5. Area is your average base times altitude, which is 9 times 6.5, which I believe would be 58.5. 9 times 6 is 54, and half of 9 is 4.5. You add 54 to 4.5. Right, figure that out. But of course, you can use a calculator. Okay, so pretty straightforward, but things to think about there. Okay, on the circle. Okay, well, let's erase that 537 pi, which is an example of how you can write an area or circumference as a multiple of pi. Area is pi r squared. Okay. Now everybody's big to pi knows that pi's are round, they're not square. It says pi r squared. It's a lie. That's a way to remember the formula. It's a stupid little way to remember the formula. Okay. It's pi r squared, which equals pi times 4 squared. You're not squaring 8, you're squaring 4. You're doing the radius. Okay. The radius goes from the center to the edge. And if you got the diameter, then of course the radius, you got a radius here and a radius here. So you got the radius twice, so you're going to take half of that, right? Radius is half the diameter. Which is then 16 pi. Circumference. It's pi times the diameter. Which would be 8 pi. Okay. Now, to see It's pi times the diameter and not pi times the radius. There's your radius. Okay, now if you go on an arc that's as long as the radius, it puts you about here. If you do it again, that puts you about here. If you do it again, that puts you about here. It puts you about halfway around, doesn't it? So if you want to multiply pi times the radius, you can just look at it and see that that's not going to give you circumference. Now, if you wrap this diameter around it, it'll take you around about there. Wrap it around again, it'll take you about there. Wrap it around again, it'll take you about there. So it's about 3 times. And pi, of course, is 3.14, the number of significant figures I expect you to remember. Right. And you should remember that. I'll say that's approximately equal to 8. That little wavy thing means approximately equal to 8. Okay. And that's approximately equal to 25 if you multiply it out. Now, I didn't do all the significant figures. Okay. It'd be 25.12, I think. Okay. Check in the calculator. I'll be just calculating it. But I think 8 times 14 is 112. So 25.12. Okay. So sometimes you will want the numerical result. So be sure you can calculate it. For right now, you want to write this. Okay. Then if you want to take your calculator and do the multiplication one way or another, you can do the approximate thing. Okay. Now find the volume of this thing. Well, the volume I think Open Math says this. I think they tell you this. Volume equals area of the base times the altitude. So they might give you length times width times width, length times width times height, LWH. Perfectly good formula, but you're better off thinking in terms of area, the area of the base times the altitude. Now this assumes that the cross-sectional area of this thing, okay, if I chop the thing, or, parallel to the base, it always has the same area. And well, that's kind of implicit. Didn't really state it, but we do that. So if the thing rises from the base uniformly, we do area of base times altitude. Area of the base is 24, 6 times 4 is 24. So I can say down here. The base area is 24. We multiply that by the altitude. And we get 300, wait a minute, 360 and 48. So 240 before, yeah, 288. I was completely out of it yesterday. I'm not quite with it today. All right. Feel pretty good today compared to yesterday. Just all of a sudden the change in weather kind of interfered with my sleep a little bit and wiped me out for a couple of days. Not real bad, but bad enough. Okay. So I still got a little bit of that effect. Okay. So we got a cylinder now. And again, it's the area of the base times the altitude. Okay, the base is a circle of radius 3. And the base is up here or down here, any cross section. And that's pi times the square of the radius. That's 9 pi. So that equals 9 pi times 8, which is 72 pi. Okay. Now we're left with the pyramid. Volume of a pyramid or a cone. Didn't ask you about a cone. Volume equals 1/3. Base area times the altitude. Okay. It's like this thing is inside of, sure I draw this about right. It's inside of a box, nice rectangular box. It comes to a point somewhere at the top of the box. If you wanted to pack this thing in a box, the box would have to be 6 by 4 to accommodate the base. It'd have to be 12 units high or long in order to accommodate the altitude. And its volume would be the area of the base, which is same as this, times the altitude, which is just what we did over here. This box would hold this pyramid. This is the smallest box, rectangular box we could do to hold the pyramid, assuming the base of the pyramid is perpendicular to altitude, which it has to be. Okay. And you divide that, you get 96. Oh, you don't. It's not times 4, it's times 12. See what I mean about not being with it? That's kind of stuff I do. So you got to watch me some days, especially in the spring. Okay. Now, does that make sense? Hopefully that makes sense. And you can follow the formula 1/3 LWH or whatever it is. Okay. But there's meaning to the formula. And if you remember the meaning, it's easier to remember the formula. And sometimes you can just bypass the formula. Okay. One of the biggest problems we have in teaching some of the more advanced courses, like, a calculus course or something, is that everybody remembers the formulas, but nobody remembers the ideas. Okay. So depending on what you're going to do as you go through your education, I say it's easier to remember these ideas than it is to remember the stupid formulas. Not always, because some of the formulas are really simple and they're not stupid. I'm just saying. So try to digest what I've got here. Because you do want to have at least that much knowledge of geometry. Okay. And I still don't have everything on the screen. There it is. And I'll be more easily able to tell. I have the presence of mind to turn on this nice big monitor down here. Okay. I got that monitor so I could look at it and see clearly what's on the much smaller screen up there. So I can see clearly whether I have this stuff on the edge. And there it is. Well, the problem is if I'm on the camera and look down there, it looks like I'm going to sleep. I hadn't anticipated that, but okay. Well, that's all we're going to talk about geometry unless questions come on. But you're going to have to apply some of this and some of the problems you're going to see later in the course. Okay. Okay, we talked a little bit about percents last time. Okay, what's 10% more than 120? Now that's one we talked about last time. So what I mean by that is it's going to be 120 plus 10% of 120, right? Not 120 plus 10 because 10% means 10 per 100. We've got more than 100 here, so 10% of this is going to be more than 10, right? And of course, 10% of 120 we understand. Is going to be 120 plus 0.10 times 120. Okay. That's 120 plus 12, which is 132. Little note here. What's 10% less than 132? You think it's 120? It isn't. Calculate it. Okay. No, I think it's important. 118.8. Actually, wait a minute now. It's out of here. Okay. I'm gonna say my brain just isn't clicking. Try to add that back up. I did something wrong. I've got it back. Okay. There we have. So that might not seem right to you, but that's just me. It means if you 10% more than 120, well, that's 12 more than 120, right? 10% of 120. Now, if you want 10% less than 132, you got to take 10% of a bigger number and subtract it. So where we added 12 here, we've got to subtract 13.2 here, and it's not going to come out the same. And the bigger the percent, the bigger the difference in that. 50% more than 120 is 180. 50% less than 180 is 90. Okay. So we started with 120, we ended up with 90. And we won 50%. Okay. So it's worth thinking about. I'm not sure that it appears in open math because I didn't have time to write a problem. And I couldn't find a problem where anybody had actually thought to demonstrate this idea. Okay. It's a real important idea. So I have more time, I'd write a problem. Or maybe I'll look again because it's been a couple of years since I designed these things. Yeah, since I chose the problems, large problem bank's bigger now. They might have something like that. I should look. Okay, anyhow, what we want to do now is let's go to the problem. 120 is 10% more than what number? Okay. Now you might think, well, 10% less than 120 is 108. You just subtract 12 from 120. But 10% more than 108 is not 120. Okay, pretty close. So the number is going to be pretty close to 108, but it's not going to be 108. Just same reason this works. Okay. If you take 10% less than the number and then add 10% to that number, you don't get as much as you started with. That has real implications, incidentally, for like financial planning, compound interest, and stuff like that. There's a big similarity there. We'll talk about some of that maybe. But maybe not. That's kind of something that we address more strongly in a later course. Okay. So anyhow, how are you going to do this? We don't know what the number is. Coincidentally, I think 10% more than 108 is 118.8. It's not 120. So if you want the number, it's what number is 100, what? Say it again. 120 is 10% more than what number? That number is going to be close to 108 because 10% more than 108 is this. And of course, 108 is 10% less than 120. We just saw that 10% more than 10% less of something is not the something. Okay. Now, what we're going to have to do let X be the number. Okay. Then X plus 0.10X equals 120, right? Yep. whatever the number is, when we add 10%, it's got to be 120 if it's the number we're looking for. Okay. And that's an easy equation to solve, isn't it? Well, you got to understand what to do with the decimals, right? So that's what do you get if you add 0.10x to x? Well, I can rewrite that as 1x plus 0.10x equals 120. Now, just like what's 2x plus 3x? Well, it's 5x, right? And x plus 12x would be 22x. If you add 1 to 1, if you add 0.1 to 1, you're going to get 1.1, right? So 1 plus, okay, x plus 0.10x is 1x plus 0.10x, which means you have 1 plus 0.10 times x. So that means you have 1.10x equals 120. And now we can divide both sides by 1.10. So we have 1.10x divided by 1.10 equals 120 divided by 1.10. And then you have to figure out approximately what that is. You can actually write the exact thing because it's going to be repeating decimal, but we'll just do an approximation. It's going to be okay. It's going to be 10, and then 1.1 into would be well, you're going to get 109. Okay. Point bunch of 0 nines, many as you want. Okay, check my arithmetic in this. You know, divide 120 by 1.10, and then take 10% more than that. If my numbers are right, you're going to get this number when you divide. It'll give you 109 point bunch of 09s. And my numbers are not right, you'll find out what the number should be, and take whatever number you get and add 10% of that number, and you should get 120, or at least very close to 120 to a bunch of decimal places. Make sense? Okay, so that's a kind of a big deal on percents. This kind of leads us to sort of first application of linear functions, linear equations. You've learned to solve linear equations. This is a relatively easy linear equation, as long as you get it through your head that x plus 0.10x is 1.10x. Okay, got to make sure you understand that. That's the biggest thing of problems of this nature. Okay, so with that, and of course with some applied problems, I'm going to leave it to you to puzzle over. If I find that you're too puzzled, then we'll talk about it more next time. but I want you to kind of think through. Okay. Another thing we have is formulas. You've seen some formulas in your homework. Let's take the formula. P equals pi r squared h. And let's just leave it there. Let's not put any numbers in it. Let's just get a formula that tells us what h is, if you happen to know the radius and the volume. Okay. For example, I could apply that to this cylindrical cup. Okay. If I could do this, I'm going to do it. Just a second. Okay, I've got this pretty accurate kitchen balance here. Even though there's things, yeah, I think I can do without floating the floor. Actually, if I hold the thing, it's not going to work too well. So I'm going to go ahead and do this. Well, I'm going to get that on. Okay. Okay, it's just spontaneous. I just happened to see this sitting there. Actually, I thought of what we could do, and then I saw this sitting on the balance. So that was very suggestive. I can fill this with water. There it is, 150 grams. Now, what am I going to do with that water? As soon as I move it, it's going to spill. It's a challenge. Let's see if I can move this thing. Not well so far. And that thing's bouncing all over the place. Surface tension's keeping it from flowing out. Get it over here far enough where I can set down. Pick it up very carefully. I think I'd be better off drinking it and pouring it out. Oh man. Oh. Ah. Blew it. Okay. That should have been easier than this. This little handle got in the way. Actually got it all the way back to the table. I don't know if you can see the surface of it, but it was all over the place. Okay. Okay, well, there's probably positive feedback on my neurological deterioration. But my judgment, yeah, it's out the window. Okay. All right. Enough of that. Okay, now what I determined was that the volume of that thing was 150 cubic centimeters. Because a cubic centimeter of water has a mass very close to 1 gram. And it can depend on the temperature because water expands a little bit when you heat it. And it also expands a little bit if you have it at 37 degrees Fahrenheit and then drop it to 32 just before freezing, it expands, which is convenient because that means ice forms on top of the pond instead of the bottom. All right. Now that would be really inconvenient. You might think it wouldn't be so inconvenient if it would be. Okay. And the diameter of the inside of this is about a little less than 5.2 centimeters. That's a little less than that, I think, but it's pretty close. Okay. So radius would be 2.6 centimeters. Now, if we then put 150 cubic centimeters in for the volume and 2.6 centimeters for the radius, we just have a bunch of numbers here with an h, and we can solve for h, right? I mean, what would we get? 2.6 squared is 5.76, and multiply that by pi, it's about 18. You get something like 150 equals 18h. So h is 150 over 18. 15 over 18 reduces to 5, not 5.6, sorry. It's about 0.84. It was 8.3 centimeters. So that thing should be 18.3 centimeters high. I've got a meter stick there, I can measure. We could test this entire experiment. Okay? Well, why would we want to then solve this? Let's say we have a bunch of containers that we want to do this with. We want to get a formula for H where we don't have to solve an equation anymore. So what we do is we solve this for H. We start with B equals pi r squared H. Now, how would we solve this to get H by itself? What would we do to both sides of this equation? Okay, because we're talking about how to do this, I've asked people, okay, write down B equals pi r squared H. Nobody wanted to say anything, but I think people had some ideas. Now that you've got that equation written down, what could you do to both sides to get H by itself? Well, what did we do to both sides in this equation? We had 115 equals 18H, right? You know darn well from what you've done in the last week or so, and probably from before that you divide both sides by 18, right? And you solve that equation, you get H. Okay, that should be pretty clear to you. What would you do to this equation? Now, again, yeah, can everybody see this? We've got 150 equals 18H. See it all right? We want to solve for H, we divide by 18, right? In other words, we divide by whatever, see what I mean? We divide by whatever is multiplying H. Well, what's multiplying H here? It's not 18, it's pi r squared, right? And of course, we got that 18. I got it by a pi r squared. It's not totally accurate, but let's see how close it was. Okay, so we got our V, pi r squared H. What can I divide both sides by to leave H here? Divide both sides by pi r squared. Make sense? And then we get just H on this side, since pi r squared divides pi r squared, which is just H, and V over pi r squared. Then we probably write that as H equals V over pi r squared. Okay. Now I don't have a calculator, handy, but numbers, and I don't know why 150 with caution will. Even though I'm neurologically okay, I'm still kind of a mess. Got to do with my sinuses, I think. Pressing the part of my brain that thinks. Okay, 150. Approximately 150 or 3.14 times 2.6 squared. Okay. Now, if, for example, I wanted to find out the height of this cylinder, well, first I'd hold my finger over this little spout down here. Okay. And it filled up with water. And I'd measure the radius. And I could figure out the height. If I've got a bunch of cylinders, so I got a whole table full of cylinders, somehow I want to find the heights. And for some reason, I don't have enough sense to measure the heights, even though I'm measuring the radius. Okay. Then you would question my efficiency. Nevertheless, you would have a method for doing it, and you have one formula. So all I got to do is plug the weight and the radius into the formula. Okay. That would be more practical to solve this for R. Because I can measure the height more accurately than I can measure the radius. So if I want to get pretty accurate measure of the radius, it's a little hard with a meter stick to get a really, really good measure of the radius, okay? I'm not sure it's not 5.1 centimeters in diameter, okay? Well, actually on the inside. It's hard to see it. So we could solve for R. Incidentally, everybody got a calculator handy? Can you punch those numbers in and see what you get? I was estimating 8.3, but I was very rough in figuring out the 18. I think that was a little high. So that might be a little bit low. Hang on a minute. Okay, the numbers we're getting, I actually measured this thing, came out like 7.5 centimeters. Okay. So people have punched a calculator, come out with things a little bit different. So not sure what's going on, but we're going to move on. It seems that we want to be able to solve a formula for one of the variables. Okay, did you get something different?
Yeah,
Hang on, Heather. Okay, we're running a little shorter time, but you know, the idea is you can solve this for one of the variables by just doing the same kind of operations you've learned to do, just adding or subtracting, same thing on both sides, multiplying or dividing. Here we divide it because the pi r squared is multiplied by h, right? been pi r squared plus h, which it wouldn't have been if it was, then I'd have subtracted pi r squared from both sides, right? Okay. You see plenty of examples. Okay, let's solve for r. Okay, I'm going to go ahead and do it since we're short on time. Trying to get r squared is multiplied by pi and multiplied by h. So we can divide by pi times h, and we get r squared equals v over pi h. Now, what do we do about that r squared? You haven't had equation, you just had linear equations, okay? But what we do is pretty simple. If r squared is a number, then r is a square root. Okay. Now, here then r would be the square root of this. Okay. You got a square root k in your calculator, right? So we've got 3 minutes. Can you punch in 150 divided by this? I'll estimate it in my head here. That'd be 22.5, and then about 4% more would be about 23.3. And about 150, if I divide 150 by 25, it's 6. And that's 1.6. Um, so part of 57 is approximately 7.6. So that comes out pretty. No, it is. Wait, no, it's not 57. It's 5.7. Never mind. 5.7. The square root of 5.7. Approximately 2.4. Get a number? Hang on a minute. That's not what I want to do.